We talk a lot about engineering things, bridges, computer chips, software, but what if we took that same incredible precision, that same scientific way of thinking, and applied it to engineering a career path? Well, today we're diving into a blueprint for learning that does exactly that.
So, what's on the docket? First, we're going to look at why we even need a blueprint for a career in the first place. Then, we'll get into the nitty-gritty of this new approach called curriculum engineering. We'll see how it all works in the real world, get our hands dirty with a super specific example from electrical engineering, and finally, we'll talk about how this whole idea could shape the innovators of the future.
Okay, so let's start with the big one, the why. I mean, the world is changing so fast, right? Technology, industry, it feels like it's a blur. The biggest challenge we face is making sure that what you learn in a classroom actually, gets you a real job.
And that is the million-dollar question, isn't it? When you've got this gap between what you're learning and what you need to do at work, you get some serious problems. Take South Africa, for example. They have this thing called an end diploma backlog. Thousands of students finish their classes, but they can't get certified because that final practical step is just missing. That's not just a gap, that's a broken bridge. So, how do we fix it?
Well, you don't build a skyscraper and just cross your fingers hoping it'll stand up, right? No way. You use a detailed, rigorous blueprint. The idea here is exactly the same, but for education. We need to design a learning path with the same care and precision as any other major engineering project.
And that brings us to the blueprint itself. What in the world is curriculum engineering?
At its core, curriculum engineering is a system. It's a way to design and manage an education so that every single piece of it, every class, every test, is totally structured and can be tracked right back to a specific career goal. Basically, it's about making sure your career is something that's designed on purpose, not something you just kind of fall into.
This whole thing is built on 4 main pillars. First, transparency. Everyone can see how the curriculum is built. Second, traceability. So you can draw a perfectly straight line from what you learn in class to a skill you need on the job. All of this is managed with integrated IT systems, and it's constantly being checked and updated, because in engineering, you're never really finished, are you?
And like any big project, there are trade-offs. The advantages, they're huge. You get these structured, traceable career paths that make you way more employable. But, and it's a big but, it's not easy. It takes a ton of resources, it can be really complicated to get all the standards to line up, and it needs constant work to stay up to date.
So we've covered the why and the what. But how does this all actually work? Let's pop the hood and take a look. You can really think of it like a data pipeline. It all starts with the inputs. What do learners actually need? What's the industry crying out for? And what are the rules we have to follow? Then you get to the processes. This is where you map everything out and align it with real skills. And the result? The outputs. Solid, structured lesson plans and a complete framework that's ready for prime time.
And this isn't just about one thing. This framework pulls in a whole bunch of different modules. Of course, you've got your hard technical skills, like engineering science, but it's right there alongside critical stuff like time management and just being ready for the workplace. It's about building a complete professional, not just someone who knows how to turn a wrench.
Now, this is where the whole engineering mindset gets very, very real. The system uses tools with names like logograms and algorithms. Just think of them as the schematics, the actual assembly instructions for your entire education. Their whole purpose is to make the learning path so clear that anyone, you, your teacher, your future boss, can look at the map and see exactly how to get from day one to job one.
Okay, this all sounds pretty amazing in theory, but where's the proof? Let's see how this framework tackles a very real, very specific problem in the world of electrical engineering science. And right here, this is the key. To make that jump in your career from being an artisan to a high-level technician in the electrical field, there's a gateway you have to pass through. And that gateway is calculus. To really get why, just look at this. To truly understand how capacitors and inductors work, you have to understand rates of change. And that, my friends, is the language of calculus.
So let's take that formula for an inductor. I know, it might look a little scary, but it's the secret code to understanding the real world. That little dIdt part, that just means the change in current over time. And understanding that, that's not just a math problem. That's what lets a technician figure out the kickback voltage when a motor starts, or find a tiny, hidden fault in a complex circuit. This is where theory becomes a skill you can actually use, a skill that gets you paid.
Okay, so that was a really powerful, concrete example. Let's zoom back out and ask the big question. What's the ultimate goal here?
What's the so what of applying all this engineering to how we learn?
This quote from Chingambe Chitati Fiston, who developed this framework, just sums it up perfectly. The whole reason for curriculum engineering is to close that gap. It's to make absolutely sure that the skills you learn are the skills that are needed, and that the path to a great career is clear, it's direct, and it's intentional.
And you know, at the end of the day, this isn't just about filling job openings. It's about a total shift in mindset. The real mission here is to transform students from being passive learners into active scientific discoverers. It's about giving them the tools for discovery and the problem-solving chops to tackle not just today's challenges, but whatever comes next.
And that leaves us with a pretty big thought to chew on. We just walked through a blueprint for one single career path. But if we can successfully engineer something as complex as an education in engineering science, what's to stop us from using this kind of thinking to re-engineer how we learn? Well, everything.